Project 2.6.2 Wireless Communication. This project extends on the previous project, which introduced mechanical components, to integrating wireless control over the mechanical object. As a reminder, the previous project used a continuous servo motor to display the Ames window optical illusion. This time, the project is split into two devices, one controller and one motor device. These devices communicate with each other by using NRF24L01 radio frequency control modules. Radio frequency, or RF, is one of the most dynamic ways of communication between microcontroller systems. The system is able to communicate in one direction, two directions, or in a web array of directions. RF operates by creating electromagnetic sine waves based on digital square waves that it receives from a microcontroller. The NRF24L01 radio frequency communicator offers frequency ranges between 2400 MHz and 2525 MHz, offering 124 channels in between. These channels provide resonant frequencies for the communicators, allowing them to distinguish the correct channel from other channels. While the NRF24L01 component communicates wirelessly with other components of its kind, it communicates with microcontrollers using SPI. The SPI controls give it a clock pulse, an input line, and an output line. It has the pins CE and CSN, which indicate whether it's actively broadcasting or receiving signals, and also determine the channel frequency that the crystal resonates at. The component creates electromagnetic sine waves by running high currents through the antenna pins. The current flow, direction, and duration indicate the power, amplitude, and frequency of the sine wave respectively. This project requires two different coding programs. The controller program is here on the right, and it contains mostly the same information for the variables that control the servo motor. It also contains new information for the NRF24L01 transmission. The motor device uses the data sent from the transmitter and sends it to the servo motor as an instruction to rotate in one direction or the other. By now being able to control the system from beyond the focal point at all times, it is possible to view all the changes that occur in the Ames window optical illusion from any point without having to come in front of the focal point. Thanks for listening.